Today, we're going to rev up our racing engines and get rolling with machine learning on AWS DeepRacer. DeepRacer is the fastest way to get started with machine learning. You don't need prior machine learning experience, and you don't even need a physical car to get started. Just come as you are, and by the end of this session, you'll be racing on the track for prizes and glory. Hi, I'm Keisha Williams, an AWS machine learning hero and a senior training architect at A Cloud Guru. Just to tell you a little bit about myself, I've been in IT for 25 years. I've built a solid career in Java software engineering, and I've held several leadership and management level positions. About 7 years ago, I added AWS and the cloud to my developer tool belt. And about 3 years ago, I revved up on machine learning. So I went from Java to machine learning. And throughout my career, I've always had a heart to teach, share, and mentor, and give back and share my lessons learned. So that is why I'm here with you today. So what's in store for the pit crew today? First, we'll talk about machine learning on AWS. Then we'll go under the hood of the AWS DeepRacer Evo. We'll learn about what makes DeepRacer autonomous and how it's able to make decisions on its own. We'll look at Evo and the sensor kit. Evo expands learning and racing with new sensors that enable the vehicle to detect objects. I'll introduce reinforcement learning. We'll look at the console with virtual racing, the simulator, and the architecture of DeepRacer. And I'm saving the best for last. Exciting changes to the AWS DeepRacer League in 2021. You're going to want to stick around for that. There are more chances to win and more chances to have fun racing. Now let's talk about machine learning on AWS. There are actually 3 layers to the machine learning stack, allowing you to start high level with a lot of abstraction and go deeper and deeper as you progress. The very bottom layer is for that expert machine learning practitioner. It's where you're working directly with frameworks like TensorFlow, MXNet, PyTorch, and you're very comfortable with building, training, tuning, and deploying machine learning models through code. Next is the middle layer of the stack. It makes it easy for everyday developers and data scientists to build, train, tune, and deploy machine learning models using Amazon SageMaker. And at the very top, API-driven AI services that allow you to easily add intelligence to your existing applications through a simple API call. Vision services like recognition, speech services like Poly, and text services like Comprehend. Now, when you think about building your own machine learning skills, or maybe the skills of your team, sometimes you just don't know where to get started. Developers typically learn by doing. That's how I learn, when I'm hands-on trying to solve a challenge or a problem. And when you consider learning a complex technology like machine learning, your success rate is much higher when you have a hands-on learning experience. There was a study from the National Academy of Sciences that confirms that students that engage in hands-on learning are 50% more likely to succeed than students using a more traditional learning method. Now, Deep Lens gives you hands-on with deep learning. Deep Composer gives you hands-on with generative AI, and DeepRacer makes reinforcement learning fun. Now make sure you check out the other machine learning sessions in the reInvent catalog, and don't miss my 15-minute dev chat on Deep Composer. I was so excited back in 2018 when Amazon SageMaker, now remember that's the middle layer of that stack, added support for reinforcement learning, because this allowed support for DeepRacer, and DeepRacer literally puts reinforcement learning in the hands of everyday developers of all machine learning skill levels. So let me show you my DeepRacer. This is AWS DeepRacer Evo. It's the newest edition. Notice Evo has 2 cameras, and this allows you to handle more complex reward environments and strategies for racing. Evo can detect objects, That's because of the LiDAR sensor up here. That stands for light detection and ranging. And it's a sensor that detects objects and it helps Evo see blind spots to avoid collision. The rest remains the same as the classic AWS DeepRacer. Even if you've mastered DeepRacer before, Evo expands the learning in racing with new challenges to solve. And if you have the classic AWS DeepRacer, all you need to do is buy a sensor kit to upgrade your DeepRacer to Evo functionality. Now, if you don't have an AWS DeepRacer, you don't have to wait for your physical DeepRacer to start racing. You can start now in the AWS console. There's a 3D simulator where the building, training, and racing takes place. You can start learning now and building models to race in the 2021 AWS DeepRacer League. Or start a league of your own with community racing tools to build models to race against friends and colleagues. Now let's talk about reinforcement learning, the machine learning technique that powers DeepRacer. Artificial intelligence is this broad and general category, and it seeks to teach machines how to do things that usually require human intelligence. Now, within this vast category of AI, there's a subset called machine learning. And within machine learning, there's even more granularity. There are several techniques like reinforcement learning, supervised learning, and unsupervised learning. Now, reinforcement learning is cool because it's learn by doing and it powers DeepRacer. Now, this is where you build a mathematical model that determines which decisions to make in an environment on its own without your help. The model is taught or trained in a simulated environment where it learns the correct actions to take based on the outcome, either good or bad, of its actions. Reinforcement learning is built on an idea that we as humans use all the time. Now, when was the last time you used a reward to incentivize the behavior of your pet or your child? Think about the method used to train a pet. We give cookies for good behavior. We don't give cookies for bad behavior. And believe me, dogs quickly learn what they should or should not do in order to get that cookie. Now, when you're successful, you've taken a regular dog and trained it into a circus dog. Now let's talk about some of the common reinforcement learning terms. First, there's the agent. The agent represents the car, and it can be physical or virtual. Next, you have the environment. This is the track or what the agent interacts with. You have state. It is the input from the sensors and the images coming from the cameras, and it helps you determine the current status of the car. Action is the decision the agent makes, so speed and steering angles. An action is guided by a strategy called a policy. Now, within the action comes the action space, and it defines the list of actions the car can take from a combination of speed and steering angles. Next, there's the reward. This measures how desirable an action is, and it's driven by the reward function that powers reinforcement learning. Next, we have the episode. This is an attempted trip around the track and what happens between the initial state and the terminating state. The key to proper behavior is this reward function. It is the most important piece because it incentivizes particular behaviors and is at the core of reinforcement learning. Now, to run your AWS DeepRacer around the track, providing a reward function will be your most important job. Let's take a look at this race grid to see a practical example of a reward function. Notice each square. Each square is a state. The green square is the starting position, while the finish line is the goal or the terminal state. The black squares at the top and bottom of the track, they represent the track edges, and they are defined as the stop states, which tell the vehicle it has gone off the track and failed. Now, the reward function is actual code that you write that helps the agent determine if the action it just took was good or bad and how good or bad it was based on the outcome. As the agent moves toward the goal, the next state is evaluated and assigned a reward. This reward incentivizes the driving behavior you want your agent to learn. Now, let's say we want to incentivize the agent to drive on the orange center line. How would we do that? By assigning a reward value to each state. Notice each square has a number, and through reinforcement learning, the car will learn which actions result in the highest cumulative reward on the way to the goal. Now, by assigning a higher reward to the center line, in this case, the number 2, our model will learn that actions that stay on the center line earn higher rewards than actions that lead to driving on the edges. Let's see this in action. Learning just doesn't happen on the first go. It takes some iteration, trial and error, multiple episodes or attempts around the track. The agent needs to explore and see where it can get the highest reward before it can exploit that knowledge. Eventually, it reaches convergence where the model starts to frequently pick specific actions based on the state it's in. In this case, it learns to stay on number 2. Notice this reward graph on the left-hand side. It connects to what you see in the console. After each episode, the agent gets a higher cumulative reward. You'll see in the console that the total reward continues to go up. On the left-hand side, this is a first-person view of what you can expect to see in the exploration phase. Cars driving off the road is common, and this is early on in the training process. On the right-hand side, you have the first-person view of what you can expect to see in exploitation. The car has learned and it's staying on the track, and this is later on in the training process. Now let's talk about this training process, which in the end produces a model that navigates the track for the highest reward. The car interacts with the simulated racetrack environment during training, with an overall goal to get to the finish line while maximizing its total reward. DeepRacer drives around the track taking pictures, about 15 pictures per second. And after each picture, DeepRacer will take an action like changing the speed or the steering angle. Now, the cool thing about DeepRacer Evo is that it has stereo cameras and LiDAR, so it has a more in-depth view of its state and can see objects as well. When the car ends up in a new state, it receives a reward based on the action it chose. Now, learning is a repetitive process. We saw that. Generally 20 episodes around the track, and you could actually control this number using hyperparameters or configuration options that you set. Now, the more it goes around the track, the more experience and knowledge it collects. And like I told you, at the end of the process, it produces a model. Now, this model can be uploaded to a physical agent, which is a real DeepRacer car, and it will use that model to navigate a physical track in the real world. DeepRacer uses a neural network architecture with multiple layers. Think of it like this. It's a way to extract patterns from images, trying to figure out which actions lead to the best reward. Now notice on the left, there's an input, and on the far right, there's an output. The output is the action to take. The neural network architecture looks a lot like this, and it is a simple 6-layer network. The first layer is an input layer. It's the image or the state. Now, in reality, it's grayscale, so the image doesn't quite look like this. Also, when you're using Evo, you're getting 2 images instead of 1, both stacked together. And if you're using LiDAR, you'll get another vector showing 90 degrees behind the car. From this input layer, the captured pixels go through a 3-layer convolutional neural network to help identify the features from the images needed to make a driving decision, like the track border, center line waypoints, infield, which is on the track, or off-field, and more. Then it feeds those features into a second neural network called the policy network to help determine which action or driving decision should be made, and that's the final output. Should the car speed up, slow down, turn left, turn right? The policy network adjusts weights to help determine which action to take. Now, weights are just the level of importance given to the input values or the features in the image in order to determine the action. Now let's take a look at the DeepRacer console. The console is an abstraction on top of API calls. Now, behind the scenes, there are multiple services that make AWS DeepRacer possible. Amazon SageMaker trains the reinforcement learning models. AWS RoboMaker provides the 3D simulation environment, and they communicate using Amazon S3. For example, the experience, things like the state, action, new state, reward, is generated in AWS RoboMaker and is used to train the model in SageMaker. And there is a lot of back and forth between the two services, a lot of iteration. Now, Amazon S3 stores the model, CloudWatch stores the logs, and Amazon Kinesis Video Stream displays the video in the console. This is the most important piece when we talk about reinforcement learning, the reward function. It's what you author in the console using Python code. Now, the great thing is, to help jumpstart you, there are 3 sample reward functions you can use to get up and running quickly. Now, during training, the agent takes an action and the position of the car is updated in the simulator. The reward function is used to determine how good or bad the outcome of the action is. Now, how would the reward function know if the outcome is good or bad? Well, after each action, you get variables containing measurements from the simulator, and you can use these variables inside of your reward function. For example, the simulator tells you how close your car is from the center of the track and how wide the track is. So you can give a higher reward for being closer to the center of the track. Behind the scenes, the reward function is a simple Lambda function, and there's a button called Validate that you can use to validate your code before you actually try to train with it. Now, let's look at track components and simulator measurements that can be used for your reward function. Oftentimes, when you're writing a reward function, you have a lot of questions. How do I know where my car is so that I can reward the outcome of an action? How do I know what to modify? Which parameters are defined in the environment? This is a first-person view of AWS DeepRacer as it drives down the track. There are several components. First, the track wall. This is the bluish area, and the camera doesn't see this area. Next, you have the field, which is considered off track, and it's green. You have the track surface, or on track, and this includes the 2 white boundary lines. And you have the center of the track, the yellow dashes. And remember, the car doesn't see yellow. It just sees a lighter color because it's all in grayscale. The car has a position denoted by XY coordinates, and there are waypoints spread around the track as a series of XY coordinates. Think of them like milestones along the way. They can be used to give hints on the shape of the track. You also have track width and track heading. Now, to clarify, the reward function is only used during the training process in order to produce the model that is loaded to the car. Now, once the model is loaded and the car is going around the track in the exploitation phase, the actions are guided by a policy, not these variables, and the next action is computed from the camera's input image. This is a variable. The heading parameter describes the orientation of the vehicle in degrees, measured counterclockwise from the x-axis of the coordinate system. All wheels on track indicates if the agent is on the track and returns true or false. Distance from the center tells how far away the vehicle is from the center line. And there are other variables available to you like progress, is reversed, and more that you can use to build your reward function. There's a new garage feature where you can customize the sensors on your AWS DeepRacer Evo and create new cars with different sensor combinations, which is so cool. Adding different sensors means your agent is capable of detecting different things. For example, it was difficult to learn the distance to an object, but now with 2 cameras, models can learn distance. In the garage, you also set up the action space. The action space defines the list of actions the car can take from a combination of speed and steering angles. Now, the more actions you provide, the longer it will take to train your model, but potentially you'll get a better range of actions as the car is going around the track. The action space is set before training, and once trained, it cannot be changed. In 2021, there are some exciting changes coming. There will be both open and pro divisions. The open division is for exploration and learning and those new to the Deep Racer experience. The pro division is for the more advanced racer. There will actually be 2 separate leaderboards. This levels the competition playing field, allowing racers of all skill levels to win prizes and recognition. You'll earn digital rewards that allow you to personalize your car in the virtual circuit, such as car bodies, paint colors, and wraps. And there will be special sponsored events with guest celebrities that can help you qualify for the Championship Cup during reInvent 2021. Community races have been around since the beginning of this year, but there are new league tools with enhanced administration features. New tools to run larger races, multi-race events, tournaments, and seasons that have championships. Admin tools to communicate with racers. You're able to see who is participating and learn more about their models. And you'll be able to broadcast races to the world via Twitch, allowing racers to compete in real time against other racers. There are several resources out there to help you get started with AWS DeepRacer, and believe me, once you get started racing, you will not want to stop. You'll enjoy spending time experimenting and tweaking with your reward function to help you move up the leaderboard. And like I mentioned, you don't even need a physical car to get started. You can do it all virtually. So drive on over to the AWS DeepRacer console and get on the track and race for prizes and glory. I will see you at the finish line. Thanks for watching.